Okay, so how do we go about finding the integral for an improper rational function? So what we are given here is we are given the numerator that has that is the degree 4. Then the denominator, it has the highest degree 3. So of course it's a rational function, and we can say it's an improper rational function. So what we need to do is that, first of all, to find the integral, we need to decompose what we have. And the first step that we have to take, since this is an improper fraction, we have to divide the denominator into the numerator. Okay, we want to try to make it a proper fraction, so that we'll be able to decompose it into its equivalent partial fractions. So the first step, of course, we try to divide the denominator into the numerator. Okay, so the denominator that we have is x to the power 3 minus 2x squared minus 7x minus 4. So we are dividing into x to the power 4 here. Okay, x to the power 4. Then I can say here I'm supposed to have to the power 3, so I'll just say 0. I'm supposed to have to the power 2, 0, 0, and a constant there. So this is 3, 2, 1 with a constant there. Okay, so you don't have to put those, but I'm just putting them just to make sure to see, as I'll be subtracting down here, there will be that kind of pair in terms of the what we have on top and that we have down. Okay, so if you say this x here, x to the power 3, we divide it into x to the power 4, you're going to find that you're going to have x here. Okay, it's like you have x to the power 4 divided by x to the power 3. X to the power 3, what you're going to have is just x there. Okay, it's what, like you have your x multiplied by x multiplied by x multiplied by x there, divide by x multiplied by x multiplied by x. That goes, that goes, that goes, that goes, and that goes, that goes, remain with that x right there. Okay, so what do we have now? So we have to multiply the x that we have gotten with everything that we have here. So that will give us x to the power 4, okay, minus 2x squared. We have 2x squared. In fact, that will be 2x to the power 3. Okay, that will be 2x to the power 3 minus 7x squared minus 4x. All right, that's what we have right there. Okay, so here we have to do the subtraction. Okay, so we can say now x to the power 4 minus x to the power 4, that would be 0. Then 0 minus 2x to the power 3, that would be 2x to the power 3. Okay, then 0 minus 7x squared, that would be plus 7x squared, meaning even here we're going to have plus what? Plus 4x. So we observe that at this point we are still able to divide what we have here into this one. So hence when we divide x to the power 3, we say 2x to the power 3 divided by x to the power 3, that will give us 2, and it's a positive, so of course you're going to have a plus here afterwards. Okay, then we multiply out, we're going to have 2x to the power 3 minus 2x minus 2x squared. In fact, that would be 4x. That would be minus 4x squared minus 7 by 2, that's 14, about 14x there, then minus 8. Okay, we have 8 there. Okay, what do we end up having? If we do the subtraction here, you're going to come up with you're going to have a 0 here, then here you're going to have 11, that because this is 7 minus 4. Of course we are multiplying everything by x squared, so that would be 11x squared. So here we are still going to have plus 18 plus 18 plus 18x plus 8. Okay, so this is what we have here. We cannot divide any further because this has the highest power 3, then the highest power here is 2. Okay, so now we have it as a proper fraction. So it basically means this can also be written as the integral of it can also be written as the integral of x plus 2. Okay, then you are saying plus 11x to the power 2 plus 18x plus 8, we divide by x to the power 3 minus 2x. Okay, we have x to the power 3 minus 2x squared minus 7x minus 4. That's what we have, dx. Okay, so now what follows is to try to, we cannot really work this out the way it is. We have to try to put it into its equivalent partial fractions. So what we want to come up with at this stage is we want to try to break down what we have on the denominator there. Okay, we want to try to break it down, and if you want to use the try and error method, you try to find the zeros of this function that we have here. You're going to find that 4 is going to be one of the zeros. If you say if we replace with 4, if I say my x is equals to 4, we see if you're going to find a 0. If we say 4 to the power 3 minus 2, 4 to the power 2 minus 7, 4 here minus 4, you're going to have 4 to the power 3, 4 to the power 3 is 64, minus 4 to the power 2 is 16. Okay, 4 squared is 16, multiplied by 2, that gives us 32, minus 7 by 4, 7 times 4 is 28, 28 there minus 4. So you find that you have your 64 minus 32 minus 28 minus 4. That will be what? 0. So meaning one of the roots of this function that we have is where we have your x, which is equals to what? Equals to 4. So to find the rest, to simplify our work here, we can use synthetic division. Okay, we can use synthetic division to try to simplify this function further. So you find that the coefficients that we have for this function, the coefficients that we have is 1, we have negative 2, we have negative 7, and we have negative 4 as a constant. So we know to say the 1 is going to drop here, and we have a 4 there as our x. Okay, so the 1 is going to drop, then 4 by 1 is 4, then minus 2 plus 4, it will be positive 2. Then positive 2 by positive 4, we're going to get positive 8. Then minus 7 plus 8, that will be a 1. So positive 1 by positive 4, we're going to get a positive 4. Then minus 4 plus 4, that will give us a 0. So meaning the function that remain with is what? Is x squared plus 2x plus 1. Of course, the remainder here is supposed to be 0. So if here we didn't get a 0, meaning the value of x that we found there we are going to say is wrong. Okay, so when I look at what I have here, I believe we're able to factorize that one. So you find that in the first place, this one was not easy for us to factorize. That's why we had to do some to try to break it down to find it in its simplest form for us to be able to factorize. Okay, so in this case, I know that what I'm going to have is I'm looking for the product and the sum. So I'm looking for two numbers. I multiply them, I get 1. I add them, I get 2. Okay, what are those numbers? Just 1 and 1. 1 by 1 is 1. 1 plus 1 is 2. So you have your x squared plus x there. Of course, the coefficient is 1. Those are the ones that I was talking about. We have a 1 here. So we factorize this. We factor that. We have your x here, x plus 1. You have your 1 here. You have your x plus 1 there. So you have your x plus 1, then x plus 1 here. Okay, so meaning what you have here, of course, is when x is equals to 1. Okay, it's when x is equals to 1. But we need to be careful at this point. As we break this one down into its equivalent partial fractions, we should not just indicate 1 simply because we know to say find both of them that x is equals to 1. No, we need to indicate it as x plus 1 squared, like that. Okay, so that means we can erase the denominator. Okay, that means we can say we can write it in the form x minus 4, which is what we have there, multiplied by x plus 1 squared, which is something that we're able to work with in terms of breaking it down into its equivalent partial fractions. Okay, meaning we have broken down the denominator. So we can say now our 11 we can say our 11x to the power 2 plus 18x plus 8 divided by x minus 4 multiplied by x plus 1 squared is equals to a divided by x minus 4 plus b divided by x plus 1 plus c divided by x plus 1 squared. So of course we we multiply everything by the denominator, which is this part, meaning we are going to remain with 11x squared plus 18x plus 8 will be equals to a multiplied by x plus 1 squared plus b, then you're going to have your x minus 4, then x plus 1, okay, plus c, then x minus 4 there. Okay, so now what follows is that we have to find what our what our a, b, and c is. And one of the easiest way is, or rather the first step that you have to take is that we know that x is one of the values here. Okay, x has a value 4, meaning 4 is one of the values of x that we have. So I can try to replace with 4 here. We see what we're going to get. So we know that if we replace with 4 here at this point, okay, we are simply talking about having 11 multiplied by 4 squared is 16, plus, so 18 multiplied by 4 plus 8 is equals to, so if I place 4 here, I'm going to have 4 plus 5, 4 plus 1 to be 5, 5 squared it will be 25, so I have 25a. So if I place 4 here, I'm going to have a 0. Okay, so we ignore that part. And if I place 4 again here, I'm going to have a 0. So meaning me replacing where there's x with 4, it will help me to find the value of a. Okay, so we can say 16 by 11 is 176 plus 8, okay, plus we can say plus 18 by 4. Okay, we get 256. 256 is equals to 25a. So meaning our a is equals to 256 divided by 25. So now how do we then come up with our b and our c? So we find that our a, okay, our a we have found that is equals to 256 divided by 25. So now to come up with our b and c, we have to expand what we have here. Okay, we have to do some expansion there. So we need to be patient with this. It seems very big, but and complex. We just need to be patient with it. So here we're going to have your 11x squared, or let me not even write that one first. Let me just do the expansion for the other part. So I know that here I have x squared plus 2x plus 1. So meaning that will be equals to ax squared plus 2ax plus a. Alright, plus a. Then what we have here is we're going to have x squared, I think that would be minus 3x minus 4. Okay, so meaning multiplying that out with a b outside, you're going to have plus b x squared minus 3b x minus 4b. Then we're going to have plus cx minus 4c. Of course, this is equals to whatever we have here, which is our 11x squared plus 18x plus 8. Okay, so at this point where we have reached, I'm looking for my I'm looking for my b and my c. So what I would want to do here is that I know to say I have ax squared here, I have bx squared, and I have 11x squared there. So I would equate those to each other. So I'm going to say my 11x squared is equals to ax squared plus bx squared. So what we are trying to do here is that we are trying to equate the like terms, and what we are able to observe at this point is that we are going to divide everything by x squared, of which the x squared is going to go. Okay, so that we don't no longer need that x squared. And we know what our a is, so we can just simply replace there. Okay, we can just simply substitute with 256 divided by 25. So we can say our b is equals to 11 minus, okay, we can say it's 11 minus 256 divided by 25. Okay, so you say 11 by 25, that gives us 275 minus 256 divided by 25. So we say minus 256, that gives us our b to be 19 divided by what? 19 divided by 25. So our b, we found that is equals to 19 divided by 25. So what about our c? What about our c here? Maybe I can try to use the constants that I have there to try to pair these up. Okay, so I have a constant here which is 8. I can say my 8 is equals to, what other constant do I have? I have a here, which is this part, and I also have a 4b. I say minus 4b. Then I also have minus 4c, there. So here is just a matter of replacing. I can say I have my 8 there, then I have my 256 over 25 minus, then 4b, I say 19 minus 4, that would be 76 divided by 25 minus 4c there. Okay, so here we can say 256 minus 75, we are going to get 181. So it will be 8 minus 181 divided by 25 is equals to 4c. Okay, so here I can say my 8 multiplied by 25 is 200 minus 181. I'm going to get 19 over 25 is equals to 4c. Okay, is equals to 4c there. So what we do here is we have to divide. Maybe just try to go through again here. We have our b to be 19. So if we say 19 multiplied by 4, we get 76. Sorry, this is supposed to be 76. Okay, it's supposed to be 76. So meaning if we say 256 minus 76, we get 180, not 181. Get 180 there. So if we say 8 multiplied by 25 is 200 minus 180, it's 20. So here, meaning this will be 20. That will be 20 there. So we can say we can divide both sides by 4. Okay, both sides by 4. We can say when you divide both sides by 4, you're going to find that and besides this, I think this is going to be a this might be a negative. Okay, yeah, that might be a negative there. So because of this negative that we have here, and I've indicated a positive, so meaning this is supposed to be a negative. So our value of c will be equals to negative 1 over what? Negative 1 over 5. That's our value of c. Okay, so we say our c is equals to neg 1 over 5. Alright, then we can take them back into the partial fractions that we are trying to put across. So we can say our a is 256. Okay, so you can say it is 256 divided by 25 multiplied by x minus 4, plus our b, which is 19 over 25 x plus 1, minus 1 over 5. You have your x plus 1 squared like that. Okay, and we can try to integrate that. So meaning what you're supposed to have here, we can express this in this form, or we can write it in this form. So instead of me having whatever that I had here, those two, that rational function, I can write plus I can write plus 256 over 25 x minus 4 plus 19 divide by 25 multiplied by x plus 1 minus 1 over 5x plus 1 squared dx. And we can express these as individual integrals. So meaning here we can have integral of x dx plus uh, integral of 2 dx there plus integral of 256 divided by 25 x minus 4 dx plus integral of 19 divided by 25 x plus 1 dx there minus integral of 1 over, in fact let me put the 5 outside, so I'll say x plus 1 squared there dx. So integrating what we have here, these are very straightforward, but I would want to stress some points on this part here. Of course, for this part and this part, we know we are dealing with natural logs. They are going to be expressed in terms of natural logs as the final answer. But for the last part, there's something that we're able to do with it. There's something that we're able to do with that one. So instead of me having x plus 1 raised to the power 2 here, I'll express this as a letter. Let me say I express it as u. Okay, so I will say I'll let, okay, we don't need this. I will say I will let u be equals to x plus 1. Okay, so meaning du is equals to dx. Okay, so you can now say what I will just try to treat this one individually, then I'll bring it up afterwards. So I'll say it's minus 1 over 5 integral of 1 over u squared du. Okay, because our du is equals to dx. So you have to say this can also be written as negative 1 over 5 integral of u to the power negative 2 du. So we integrate with respect to u. So of course we know we are supposed to add the 1 there, then divide by 1, so that would be minus 1 over 5. You're going to have your u, then you're supposed to have minus 2 plus 1 divided by minus 2 plus 1 there, of which this is going to give us, if I to write this side, that is going to give us minus 1 over 5. Then you're going to have your u to the power 1 to the power negative 1 divided by negative 1, of which this negative and that negative is going to go. Okay, that's going to go. We're going to have a positive, and we are going to write this as 1 over 5 1 over u. So this is just simply 1 over 5u. Okay, that's the integral, but we have to we know what our u is. So we know that our u is equals to what? Is equals to what we have here. So we can say it is 1 over 5 1 over 5 we have 1 over 5, which is x plus what? X plus 1 there. Okay, so is there anything else that we're able to do with that? I don't think so. We can leave it the way it is. So we can do with this one, that would be our x squared over 2, okay, plus 2x plus you're going to have your 256 over 25 over 25 natural log of x minus 4. Of course, absolute value, you're not supposed to get a negative there. So plus 19 over 25 natural log of course, absolute value of x plus 1, like that. Then that we have found that it's plus, we can write it as what? As plus 1 over 5. Instead of putting it on the denominator, I'll say it is natural log of absolute value of x plus 1 and plus c there as a constant, and this is simply the integral of this one here. So it was just a matter of breaking it down into its equivalent partial fractions. But of course, noticing that this is not just any rational function, this is an improper rational function, hence we have to do some division. If you just break down directly, you're going to get something that is wrong. So first of all, you have to divide. Then after that, when you have it as a proper fraction, or rather as a proper rational function, you can do the splitting into its equivalent partial fractions. So that's all in this video. Thank you very much for watching.